students, how are you all? I hope you all are fine. So here I am today again for our very new chapter of class 7th series, that is motion and time. Do you remember that we have learned something about motion in class 6? So let's quickly revise it first and then we will continue with this class 7, okay? Alright students, so what we have learned in class 6, let us just revise about what is motion. So I have already told you in class 6 that motion is known as something as the change of the position of a body with respect to time. As we are moving, we are just performing motion from our body. We are moving per unit time. Motion is related to the time. If we want to calculate motion, then we say then we try to say that a car is traveling 8 kilometer per hour. That is, the car is traveling 8 kilometer per unit hour, means 1 hour. In 1 hour the car is traveling 8 kilometers. Okay, so here in the 6th class we have learnt about different type of motions, in which we have learnt about the circular motions, in which we studied that the motion which always takes place in circular direction. Okay, always in circular direction, that is circular motion. And then we have studied about rectilinear motion. So what we have studied in rectilinear motion, the motion that always takes place in a provided single direction, means where the direction is being prescribed, that any vehicle, any object must travel in a straight line or a straight path. And also we have learnt about the periodic motion, the motion which keep on repeating itself in a particular length of time. Okay, so in examples we have learned that the rotation of the earth around the sun, which repeats itself for our 365 days, and rectilinear motion, handles of a bicycle, which is always straight. Okay, and examples in circular motion, we have learned different types of paddles, or obviously there are some rides which are only moves in circular direction. Okay, so these were the types of motion we have studied in class 6. And also these are the examples where you can see a car which is moving in a rectilinear direction because it's moving in a straight path. The ball, where you can see it is also moving in the straight direction. The clock, which is a circular motion, right? All right, so we have already studied in class 6 about these what is motion and what are the types of motion. Also we have done the measurement of this motion, right? So if you want to learn more about the motion, the conversion of motions, so you can just go through my video of class 6 series, and there you can find out the video and you can revise the motion. All right, now we continue with the class 7. All right, so that was a quick recap with class 6. Now we are going to start with our class 7, motion and time. Let's see what this chapter has for us. All right, so first we are going to start with what is motion, and then we are going to learn about two different types of motion as well, as we have studied in class 6 about different types of motions. So there is two add-on in this chapter. First we will define motion, and then we will learn about two types of motions we're going to see afterwards, and then we are going to learn how do we calculate motion and what else is required to know more about motion. Okay, and then we will see how the motion is described on a graph paper. Okay, we are going to learn some interesting graph as well. Okay, regarding distance, speed and time, because we already know that motion is how fast something is going with respect to time. Okay, as we are making any motion, we represent motion with respect to time. Always remember, the motion is known as how fast something is traveling or going with respect to time. So for example, as you can see on the screen, this car is going 60 miles in 1 hour, has a speed of 60 miles per hour. Okay, or you can say 60 kilometers per hour. Okay, so it tells us how much distance something can cover in a certain amount of time. So motion is have a certain aspects. Okay, it compose of speed plus distance and time. All three in one means motion. Okay. Okay, so from now on when I talk about motion, there is something which is included in reference to speed, distance and time of a body. Okay, so two types of motions that we are going to study. We have already studied about periodic motion, the motion which repeats itself. Okay, repeats itself with a regular interval of time. Okay, that means, for example, week. Okay, in week we have 7 days. Okay, so it is particular that it will move as in a periodic motion. The calendar will move as a periodic motion. So after, when Sunday comes, so after 6 days again Sunday will come. So this motion is repeating itself, no? Likewise in clock also we can see one time in a day 12 p.m. it is, and then it become 12 a.m. It means the clock is striking again 12, and also if there is 2 a.m. there is also 2 p.m. Likewise to every time there is repetitive motion in a particular regular interval of time. So we consider this type of motion which is repeating itself in a particular regular interval of time, we call it as periodic motion. Likewise in our solar system also, earth is revolving. So it is revolving in a periodic motion. So it is repeating itself, like, okay, non-uniform motion. So in regardless with the periodic and non-periodic motion, there is another two type of motion which is uniform motion and non-uniform motion. So can you guess how these cars are traveling? Cars are traveling in a traffic. Do they attain a constant speed while traveling? If they are going fast, are they moving fast in a traffic also? What do you think? No, it can't happen because car is being stuck inside with the traffic flow and it can't move further. Okay, and it cannot attain its constant speed as well. Constant speed means uniform speed which he was attaining prior to the traffic. Similarly, in the drifting of a boat in a wind where waves are higher and slower like this. Okay, so what do you think? The boat will attain a constant speed or it need to be sometimes fast, sometimes slow, right? So what type of motion these cars in a traffic and a drifting of a boat suggests that they are traveling in a non-uniform motion which is not constant at all. Road is almost vacant, right? Empty. When the road is empty or vacant, so the car has acquired the space it need to travel and it attain a constant speed without any traffic. It is traveling, okay, without any disturbance. So this kind of motion in which the vehicles or objects are moving in a constant speed, in a uniform motion, okay, so we refer that motion as a uniform motion where there is no fast or slow movement. There is only one constant speed of a object or a vehicle. This was all about uniform and non-uniform motion. These differences are surely in paper, in exams, they will ask you, examiner will ask you to tell differences between uniform and non-uniform motion. All right. Okay. So this was all about the motion and different types of motion. That is, we have learned about periodic, non-periodic, and also we have learnt about uniform and non-uniform motion. Okay, so I already told you that motion is a word which comprises of three things, right? The speed, the distance, and also time. So now if we want to calculate motion, we need to know this, okay, at how much speed the vehicle is traveling, how much distance the vehicle has to cover, and how long the vehicle have to travel, okay, to cover a certain distance. All right. So how we are going to calculate speed, distance and time, we are going to learn now. Okay. All right. So since we have said that these speed, distance and time are interlinked to each other. All right. These speed, distance and time are interlinked with the motion. Okay. So we will first define speed, distance and time. How are they related? And then we will going to solve some numericals on it. Okay. And then we will learn about a graph. Okay. So what is speed? Speed tells us how fast something is traveling. How fast the train is against a car, bicycle, only if we know the speed of every vehicle. So speed decide how fast something is traveling or moving. The greater the value, the fastest it's going. Okay. And common units of measurement, if you want to calculate speed and we are giving the answer, so always remember with the answer, for suppose we are giving the answer that it travels 8 kilometer per hour, we need to define the unit as well. So SI unit of this speed is kilometer per hour and miles per hour. Okay, you can write it like this: kilometer per hour. Per means 1 unit. In 1 unit of hour, something is traveling 1 kilometer or 8 kilometer or 7 kilometers. You getting my point? Likewise, in distance is the amount of space between 2 points, like this point A and this is point B, right? So amount of distance in between these two objects is referred to as a distance. So object covers. So if the vehicle has to cover this much distance, I already told you that motion defines how much this vehicle has to travel, means how much in how much speed, at how much speed, and at how long the vehicle has to travel. So that will define the time, the period it takes to travel a certain distance. SI unit, always write the SI unit with the answer. It can be hour, minutes or seconds. Likewise in distance, we already know that we calculate time in kilometers or meters. Okay. All right. So how are speed, distance, time and related? In order to calculate the motion, which is speed, distance and time, we have a formula, quick formula. Speed is equal to distance upon time. Speed equal to distance upon time. You can find the speed of an object if you know the distance it travel and the time elapsed to travel the distance. Time elapsed means time taken, okay, by the vehicle to cover the so and so distance. All right, let us see within okay, example we are going to see afterwards. First we will see how the question will come. If the question is asking how fast or how long, how far means it is asking about the distance. The question will not directly come to tell the distance. The question has a word problem. There is a statement where it might be written how far the vehicle has traveled. So it means the examiner is asking to calculate the distance. And how long the vehicle has traveled means the question is asking how long the time has been taken by the vehicle to reach so and so destination. Okay, how fast means speed. All right, the examiner is asking about how fast the vehicle has been moved or traveled. You got my point? All right, so here is an example. Eva run from her home to sports complex in 1 hour 30 minutes. Okay, 1 hour is the time. Okay, 1 hour 30 minutes is the time. All right, and here is the, if Eva has an average speed of 9.33 kilometers per hour. 9.33 kilometer per hour is her speed, right? So we got the two values, that we have got the speed and time. What is missing? Come on, tell me. Yes, the distance is missing. How far? See, the examiner is not asking directly, tell us the distance. No, he is asking how far she was able to travel. Okay, so we will calculate with the same formula. Our root formula is speed is equal to distance upon time, right? So we have to take out distance. So for distance, we will take this cross multiplication we will do. So S multiply T means distance is equal to speed into time. Alright. So it was all about the cross multiplication we will do. Okay. So likewise, distance is equal to speed into time, and here is the answer when we will just multiply this. So approx 14 kilometer is your answer, right? So always remember the unit. You need to mention the unit with the answer always. Okay. When you're writing speed, there is the two possibilities: kilometer per hour and meter per second. Okay. Do not write kilometer per second. Second is always with the meter and kilometer is always with the hour, right? So kilometer per hour and meter per second always. Okay. All right. So here is the numerical for you. You have to calculate who is the fastest between these two vehicles, the car or a bus. Who is the fastest? So here is the speed written. Speed of a car is 75 kilometers per hour and the bus is 50 kilometers per hour. So who is the fastest? Yes, the car. Okay. Always make sure these units should. So these are the features, or you can say differences between speedometer and odometer. It mostly asks in the questions to write difference between the speedometer and odometer. You can check the answer from here. So speedometer measures the current speed of the vehicle. Odometer measures the total distance traveled. Shows the speed at a given moment. Okay. And odometer tracks the cumulative distance, means total distance. Okay. Total distance traveled. And speed in miles per hour. Okay. Unit. Total distance in miles or kilometers or meters, or basically kilometers because it is present inside the car, right? So it is the location of the speedometer is on the dashboard, usually near the center of a car. Dashboard often integrated with speedometer. So this is the dashboard of a car where these two tools you can see. Okay. So helps to monitor the speed with speed limits, helps track the vehicle, usage for maintenance and resale. Okay, so now we are going to learn about the motion only, but on a graph paper. Okay, so it is wonderful that the science has given, or this calculation makes our calculation method easy if we involve the graph with our calculation. So what we are going to learn in these graphs, first we will explain what is the distance time graph is all about. And then we are going to interpret the slopes in distance time graphs. What are the slopes which comes in the distance time graphs? How these slopes are being observed? What are these slopes are known as? Okay, how steeper the slopes are we going to study in these graphs. And then we are going to calculate the speeds in the distance time graph. So in reference with the graph, how we are going to calculate the speed we are going to see. Okay. So distance time graph. First we have to know what is distance time graph is all about. So distance time graph is a graph that shows how an object's position or distance covered change over time. Okay, with respect to time, how the vehicle is changing its position, how the vehicle is covering the distance, how much the vehicle is covering the distance, how longer it will take. So with reference to time, the distance time graph is made. I am going to show you how this distance time graph is made. Okay. Now the gradient means the changes which are coming, right? The gradient here in a scientific term or in a graphical term, we represent the change or curve in a form of slope. Okay. Of the line tells us about the speed of travel. The steeper the line, the faster an object is. Steeper means you have seen the stairs, right? It go like this, right? So longer the steeper, the faster the object is. Okay. So then after all this, when we have interpret the whole graph, then we are going to calculate the speed. So with the same formula, which is speed is equal to distance upon time. But the thing is, we are going to represent all this distance and time on a graph paper. Okay. All right. Let's find out the distance between our school and one of these destinations. How long would it take to get there, and what means of travel should we consider? Obviously, we going to travel with the train, not with the bicycle, right? So here is an example for you. So Tisha left home and walked at a constant speed for the first 6 minutes. So she is walking in a constant speed means in a uniform motion. Okay. Because there is no curves in between, no hindrance, no disturbance. So she is walking in a constant speed of, speed has not been mentioned, constant speed for the first 6 minutes covering 20 meters. Okay. So here is the distance being given to you. She saw her best friend and they stopped at a corner shop for 2 minutes. They realized they would be late for their class and decided to walk at a constant speed covering 60 meters in just 2 minutes. Okay, 60 meters in just 2 minutes. But after the pause she has taken when she met her friend. Okay, how can you organize the given details and model the change in Tisha's position over time? So we are going to interpret this is a graph. We can use the distance time graph. So here is this y-axis and this is known as x-axis. Okay, so here we can then use a distance time graph to plot the data. So here in a graph I'll tell you in a graph there are two axes in your graph paper. Graph paper look like this. Okay, so there are two axes, this one and this one. This axis is known as x-axis and this is known as y-axis. Similarly, in in your maths class, you point this A, B, C, right? So in a graph, we work on axis. This is your x-axis and this is your y-axis. Margin, you mention margin in your notebook, right? In a graph, we mention y-axis and x-axis. So here we will mention the distance and here is the time. Okay, so the measurement has been given 60 meters. It was the maximum distance traveled by Tisha, and this is the time. This is the 10 minutes which have been mentioned by Tisha. So the gradient of the line means the change of the line or slope on a distance time graph tells us about the speed of an object. A straight diagonal lines means the object is traveling at a constant speed, means uniform motion. So he took a rest, right? A stationary object means object which is not moving. Object which is not moving is known as stationary object. So when Tisha met her friend, so she stopped moving. So here is the rest. Tisha is taking rest. And then the slope keep downward because the motion is slow now. Okay. Now a stationary object does not change its distance even if the time increases. So this will be flat. Yeah, generally the examiner also asks you what they will do. They will give you the picture of a graph and then they will ask you the question what this graph is about. Is it in a rest position or in a constant position, constant speed? So you have to mention like this. This is at rest position and this is the constant speed position of an object. All right. You must be familiar with the graph. At rest, the Tisha is stationary when she was meeting with her friend. An object moves fast at a constant speed. Tisha is walking speedily at a constant rate. So these are the graphs which are definitely going to come in your exams. In the same way, the speed is equal to distance upon time. We're going to look at it. So here it is. This is a constant speed. And this is a rest and again this is a constant. So how we are going to calculate change in y values and change in x-axis. So here you can see, so this is your 20 meters and this is your 6-minute timing and here is your answer with the same formula, distance upon time taken. Okay, this is your distance which is 20 and this is your time which is 6. Okay, so Tisha walked at a speed of 3.33 meters per minute in section A. Now we have to calculate Tisha's speed in section C here. So what we are going to do, you can see this is the another, here is the C point, we have calculated the A point. Now you can see how this is the interlinking point, right? So 60 meters in how much minutes? Time. So this is your distance, this is your time, and the answer is this 20 meter per minute. Okay. So this was all about your class, and in the next part we are going to learn about, we are going to calculate certain numericals on the topic motion and time, and also we will cover NCERT exercises. So stay tuned and keep on learning and keep on revising. Bye bye, take care.